Welcome to Amplifyre's interview series. My name is Kristijan, and joining me today is a software developer at Arthaus, which also happens to have one of the greatest names as well, Kristijan. So Kristijan, welcome to the series, my friend. How are you today?
Hi, Kristijan. Thank you for having me today. I am doing quite well, and it's great being with you here. How are you?
Yeah, I'm very good, and I'm excited for today's interview because it's also a topic that, me personally, I don't have a lot of knowledge in, so I'm sure it's going to be a quite educational interview today because we will be discussing the important topic of security in Laravel applications. So maybe to start us off, Kristijan, what are hashing and encryption and how do they differ from each other? And what are some practical examples when using each technique?
To start explaining hashing and encryption, let's start by imagining having a word or a secret message that needs to be kept safe and protected from others. This can be anything from our Facebook password to our credit card number, or it can even be an embarrassing love letter, for example. So when we run a hashing or encryption algorithm over a plain text string, it becomes something unreadable. However, the difference between hashing and encryption is that the encrypted value can be converted back to its original value, while the hashed value cannot be reversed. A good analogy for hashing would be mixing colors of paint together and getting a completely new color. We cannot simply separate the colors and get the original ones back. While encryption is more like having a secret diary with a lock on it. We choose who we give our keys to so they can unlock our diary and read our secrets. This is why they have different use cases when it comes to creating Laravel applications. For example, when creating a new application with Laravel, it is very convenient to use hashing for storing user passwords. So in a case of a security breach where an attacker gains access to our database, they won't be able to read the passwords. On the other hand, a good use case for encryption is, for example, storing medical records, medical data, that should be only accessible by certain individuals, such as doctors, patients, administrators, and so on. So, in short, we use hashing for information that doesn't need to be readable as plain text, and encryption for information that should be readable after decrypting, but of course by only specific individuals. Additionally, encryption can be symmetric or asymmetric by its nature, making this topic even more interesting.
So let's have a quick chat about that. You mentioned symmetric and asymmetric. So what are the differences between the two in terms of encryption, and when should you use each type of encryption in a Laravel application?
The difference, basically in a nutshell, is that the symmetric encryption uses a single key for encryption and decryption, while the asymmetric encryption uses a pair of keys. A real-life scenario of using a symmetric encryption is sending a password-protected PDF file to someone else. That means that we have the encrypted file with a password, but the problem here is how to securely send the password to the recipient without having to worry about that someone can intercept our message and decrypt our secret file. This is where the asymmetric encryption comes into play and solves this issue by using a pair of keys, which are mathematically linked to each other. The first one is called public, and it's intended to be shared with the public, while the second one is called private, and it should not be shared with anyone else besides ourselves under any circumstances. So next time when we would like to send a file, by using asymmetric encryption, we should encrypt the file with the recipient's public key, and we don't need to put an extra password. After receiving the file, the recipient can simply decrypt the file by using their private key, and the file transfer is successful and secure. An interesting practical use for symmetric encryption in a Laravel application would be, for example, confirming someone's identity, or confirming their payment info by typing the last 4 digits of their credit card number. While for the asymmetric encryption, a practical use case would be creating, for example, a blockchain application, an application that uses digital signatures, or it can be a chat application, for example. By today's standards, symmetric encryption is considered to be a relatively simple cryptographic algorithm, but once it was considered a state of art, and it was used by the German army in the Second World War.
Continuing on the subject, how can Laravel be used to securely store and manage password hashes for user accounts, and what methods can be used to prevent, password cracking and brute force attacks?
Laravel as a framework provides a wide range of features for web development, including password management, storage, security, and so on. As we have mentioned previously, the best way to store passwords is to hash them, so no one can access them in plain text format. Under the hood, by default, Laravel uses an algorithm called Bcrypt. It's being used for hashing the passwords before they are being stored into the database. In hashing, every hashed value is fixed in length, but with every change, the output gets completely different, even if the change is just a single character. This is why Laravel implements two more techniques. They are called salt and pepper. They both are basically random strings that are being attached to the plain text password before it's being hashed. But the difference between them is that the salt is generated every single time when a new record is stored into the database, and the salt is stored into the database along with the hashed value, while the pepper is stored in the source code of the project itself. To even further enhance security, Laravel supports something called rate limiting and something else called key stretching. With the rate limiting feature, Laravel limits the number of login attempts in a given period of time. This is for preventing brute force attacks. While the key stretching technique tries to prevent rainbow table attacks by simply running the hashing algorithm multiple times over the same value. At the end of the day, since we can't be sure of the security of the hashing algorithm used by our service providers, we can come to a definitive conclusion that we should always use strong and complicated passwords without exception.
It's super interesting. I think it's a topic that can go on for a long time in this discussion. But since we're just running out of time, I got one more. I think probably one of the most important questions of today. If people are interested in finding out more about Arthaus, where can they go?
They can visit our company's website. That's arthaus.mk. Our website provides information about the company, its services, portfolio, contact information, and everything that's relevant about the company. And additionally, people can contact Arthaus through email, which is listed on the website, and they can request more information about the services that we provide.
That's brilliant. Kristijan, I gotta say, really interesting topic, especially in today's, world when it comes to all of our lives being digitized. It's a very important topic that anybody should take into consideration when they're building a product. So I just want to say one more time, thanks for joining the interview today. It's super interesting.
Thank you for having me today. It was my pleasure being part of your interview series.